You might not realize it, but every time you watch a video on YouTube, scroll through Instagram, or stream a playlist on Spotify, you are interacting with Python. A lot of people assume coding requires advanced math or a complex understanding of machine architecture. But really, writing code is just giving instructions in plain English. Python is simply the translator sitting between your logic and the machine. In the next few minutes, we are going to walk through how this translation actually works. By the end of this lesson, you will have moved past theory and written a real, logic-based program from scratch. Mastering Python means learning how to clearly communicate a problem to a machine, step by step, so it can do the heavy lifting for you. To get the computer to talk back to us, we use the print function. If we type the word print, open a parentheses, and add the words hello world, the terminal will display our exact message. Notice those quotation marks around our text. They are required because they tell the computer that the words inside are human language, what programmers call a string, and not a piece of programming instruction. This line demonstrates how programming works at its most basic level. You provide a specific instruction, and the machine carries it out exactly as asked. If we want to build a useful program, like a check-in system for a hospital, the computer needs a way to remember information, like a patient's age. We use a variable. Think of it as a simple storage box. Inside, we store 4 basic data types: whole numbers, called integers, decimals, called floats, text, called strings, and true or false answers, called booleans. You have to be precise when creating these. Python is highly sensitive to uppercase and lowercase letters. A lowercase t for true breaks your program, but an uppercase t is a valid boolean. Variables and data types are the raw ingredients of any application. Without them, your program has no memory, and your computer has absolutely nothing to calculate. Now, let's have our program ask a direct question using the input function for their birth year. We calculate their age by subtracting that year from the current year, but when we do the math, the program suddenly crashes. The computer reads 1982 as a word and can't do math with it. To fix this, we use type conversion. Wrapping our input in the int function translates that text into a whole number, allowing perfect subtraction. A red error screen is the computer's way of asking for more specific instructions. It's an opportunity to clarify your data types so you both speak the same dialect. A smart program needs to make decisions. It must react differently depending on the user's choice, like calculating weight in kilograms or pounds. We build these decisions using if and else statements, which act as a fork in the road for our code. We use the double equal sign to compare values. To tell the computer which instructions belong to which path, Python uses indentation. By tabbing inward, we visually group our code, ensuring it only runs when the condition is met. Adding these logical conditions turns a basic script into a smart application capable of dynamic problem solving. So far, we've handled single pieces of data, but what if our hospital program needs to process 100 patients at once? Storing them in 100 separate variables would be incredibly inefficient. Instead, we use a list, a single variable holding a collection of items, organized in square brackets. To protect vital data from changing, we use a tuple, which uses parentheses. Once created, its contents are completely locked. Once grouped, we process data using loops. They let the computer instantly repeat actions across an entire list without writing extra lines of code. Collections and loops give you massive leverage. They allow you to automate repetitive manual tasks, executing hours of work in just milliseconds. Let's bring all these concepts together. Here is the final structure of our weight converter application. We have variables holding memory, input functions gathering text, type conversion turning that text into math, and if statements routing the logic. When we execute this code, the terminal asks a question, accepts a human answer, safely routes it through the logic we built, and prints a perfectly calculated result. A few minutes ago, this wall of code might have seemed completely unreadable. Now you can see that it is just a logical sequence of simple rules. The only way to truly learn this language is to speak it. Download Python, open up an editor, and write your very first program today.